Welcome to a video looking at how to integrate trigonometrics using U-Substitution. This is part 2 of the series How to Integrate Using U-Substitution, where we're having a closer look at what to do when we have sine, cos and other trigonometric variables or functions. Right, if you've watched the first video in the series, you should have realized that a big part of the trick of the U-Substitution is knowing what the u value will become once it's differentiated and put back into the integral. Now, if you do the u-substitution correctly, there will be a way of cancelling out this modified u value with the what's left over from the original function. Now, with x squareds, obviously you differentiate that, you get 2x. So if you have a 2x in the original function, or any variable of x to the power of 1, you can cancel the x's out, and any coefficients can be put outside the integral. However, you have to be a bit more on the ball when it comes to trigonometric functions. So the first step we're going to do in addressing this question, which is the integral of sine theta and cos to the 7 theta d theta, is to note that cos to the 7 theta can also be written as follows. Now, what you notice here is that we have a more familiar looking equation. We can consider this as the u term, cos theta, because cos to the 7 theta is a whole different kettle of fish to differentiate. So if we take u equals cos theta and differentiate u with respect to theta, we of course get minus sine theta. Now we rewrite that in terms of d theta. We get minus du over sine theta just by rearranging the terms or multiplying throughout. Whichever method you feel most comfortable with, essentially it's the same thing, just different ways of addressing it. Okay, now what we can do now is substitute d theta and our u equal to cos theta back into the original equation. So now we have the integral of sine theta times by, instead of cos theta to the 7, we have u to the 7, and instead of d theta we simply substitute in, and I'm going to use a bracket because we have a negative term. That again is a matter of preference. Now, because we've done this correctly, the sine theta terms can be cancelled out, and we are left with only u terms du with respect to u. Now we can take the minus 1, because it's a coefficient, outside of the integral, so that's no problem. So we have minus 1, and we simply integrate that. So we have minus u to the 8 over 8 plus c. Now we simply substitute back in for our value of u because we want it in the original terms of theta, and our answer Now remember that minus cos theta to the 8 is the same as cos to the 8 theta. Thank you for watching. I'm going to do a slightly more complicated question that I've invented, if you will, in the next part of the video, so have a look at that one. Cheers.